Liking this video will help this channel to grow. So please go ahead and give this video a like.
Continuing from section 3 of our lessons on probabilities, this section will be on calculating relative frequency and expectations. As usual, remember to give the video a thumbs up and also share with a friend and let them know how helpful these lessons have been. Now, let's look at relative frequency. In an experiment or a survey, relative frequency of an event is the number of times the event occurs divided by the total number of trials. Now, relative frequency is used for experimental probability when we are doing an experiment to ascertain how many times we expect something to occur. Now, experimental probability is different from theoretical probability as it is based on the actual occurrences and not on theory. So, for example, the theoretical probability of rolling a 6 on a die is 1/6, since there is just 1 6 on the die. However, the frequency or the relative frequency, if we're doing an experiment, will depend on the number of times we have rolled that die altogether. Now, to calculate our relative frequency, the formula is that relative frequency is equal to the frequency of the event that we're looking at, how often does it occur, divided by the total number of trials in that experiment. So it's a good thing for you to pause the video and write the formula down, and then we're going to look at some questions. So frequency of the event occurring divided by the total number of trials that we have conducted in that experiment. Now the first question here, we're told that Tia rolls a die 60 times. The table shows the results. So the number on the die, 1, 2, 3, 4, 5, and 6, and the frequency of each number is shown below the numbers. We are asked to say what is the relative frequency of a 2. So if we look on the table here, we can see of 60 times, 9 of those were 2s. So the relative frequency, which I'm going to call RF, would be equal to 9 of 60 trials. So 9 is the frequency of 2s. Total trials is 60, so that is equal to 9/60. That can also be further simplified because I can divide both numerator and denominator by 3. So 3 into 9 goes 3 times, and into 60 goes 20 times. So we could simplify 9/60 to 3/20. Absolutely brilliant. So now we're going to look at another example. We're told here that Lucy throws a die 50 times and also her results are shown. This question now we've got to be careful. Question says work out the relative frequency of throwing an odd number. So first of all, we have to know what our odd numbers are. So from the table here, we can see first odd number is 1, so frequency of 1 is 7. Second odd number is 3, frequency of that is 12. Third odd number is 5, and the frequency of that is 9. So to get our relative frequency, we need to add all of these together and then write that as a fraction of the total amount of throws, which is 50. So we go for 7 add 12 add 9. So 7 add 12 is 19, and 19 plus 9 is 28. So therefore, we get 28 in total for the odd numbers. We then need to write that as a fraction. So it's 28 out of the total, which is 50. That could also be simplified, or remember, probability can be written as a percentage or as a decimal as well. So if I wanted to scale this up, I could times by 2 to get to 56, and my denominator will get me to 100. So that could also be 56% or 0.56, or I could simplify the fraction. Half of 28 is 14 and half of 50 is 28, or I could say it's 56%, or we could write that as 0.56. Beautiful. So now that we've looked at how to write our relative frequency down, we're now going to look at expectation. So when we talk about expectation, it is the number of times you expect an outcome to happen in a particular chance situation. Okay, so it's a chance when you throw a die in a game, you're trying to get a 6, it's just a chance, 1 out of 6 options for you to get that. So expectation is calculated as your relative frequency multiplied by the number of trials that we've done. So now that we know how to write down our relative frequency, we can now calculate expectation by doing the relative frequency multiplied by the number of times we have tried that event. Okay, so first question on expectation. We're told here that an ordinary fair die is rolled 120 times. Underline. How many times would you expect to roll a 6? Now, because it's a fair die, every number on the die has an equal opportunity of occurring. So the relative frequency of rolling a 6 on a die is going to be 1 out of 6. So because it's rolled 120 times, it's our relative frequency multiplied by our number of trials. So we're going to do 1/6 multiplied by 120, which is the same as 120 divided by 6. So 12 divided by 6 is 2, and 6 into 0, 0. So that will be 20 times we are expected to get the number 6 in that particular experiment. Beautiful, very nice and very simple as well. So guys, we're going to go into another question. So in this question, we're told that an experiment is carried out 200 times. The possible outcomes are K, L, and M. So we're given those outcomes on the table. We've got missing sections that we need to complete on the table. So part A says complete the table. Part B told us altogether experiment is carried out 500 times. How many times will you expect to get the outcome to be K? So we can calculate part B, however, we were asked to complete the table. Now, for the frequency, we can see we don't have the frequency for M, but we know the total is 200, so I can find out the frequency for M by doing frequency of M is equal to, number of times was 200, so we need to take away the sum of 84 plus 54 from 200. So we do that. So 200 take away the sum of 84 and 54 is 158. So that leaves us with 62. So we're going to put that on our table. Now for the next bit, we want to calculate the relative frequency. So remember, relative frequency, how did we get from 84 to 0.42 in the table? We had to do 84 divided by 200, and that's how we got our 0.42. So same principle apply. To get 54, the relative frequency of L then would be equal to 54 divided by 200. Just going to quickly calculate that. So 54 divided by 200 is 0.27. I put that in my table. Now for M, I can either add 0.42 and 0.27 and subtract it from 1, since probability adds to 1. Or I could just do the same, 62 divided by 200. And that will get me my answer. So 62 divided by 200, that gives me 0.31. So now I have completed the table. Question then asks me for part B, Altogether, the experiment is carried out 500 times. We want to know how many times we expect to get K. So again, remember, expectation is equal to relative frequency multiplied by the number of trials. So the relative frequency for K, as we can see on the table, is 0.42 multiplied by the number of trials here, which is 500. Put that in our calculator. So 0.42 multiplied by 500 gets us 210, and that is our answer. So you can see how we put our relative frequency and our expectation together to find the total number of times we expect an event to happen. So guys, we're going to do our final question and then we're going to wrap up. So we're told here, we're given this spinner and we're told that the arrow is spun 72 times. We are asked how many times do you expect the arrow to land on a 4? So for this question, we have to look at the number of sections or on the spinner, and we've got 6 sections. There is 2 4s, so it's going to be 2 out of the 6. Which we can simplify to be 1/3, but it says how many times do you expect the arrow to land on a 4? So now that we wrote our relative frequency, we can now multiply that by the total number of trials. So it's 1/3 multiplied by 72. So therefore, we're just simply doing 72 divided by 1/3, which is going to give us 24 times. Now, a connection for this question tells us that an arrow on a different spinner is spun 250 times. Some of the results are shown in the table, but some of the results are missing. The relative frequency of landing on a 4 is the same as the relative frequency of landing on a 5. Work out the relative frequency of landing on a 4. So all of this question together is 5 marks. So 2 for the first, and the last one here is going to give us 3 because we've got to do a little bit more calculation here. But I know that the 2 for 4 and 5 should be the same. So what I've got to do is to add all the other frequencies together, then subtract it from the total, but I will now have to divide this in half to get 1. So to calculate a 4 or a 5, that's going to be equal to 25 plus 53 plus 62, subtracted all the way from, so we're going to add this together, get a value, and then we're going to subtract that from 250. So let's get our total for 25 plus 53 plus 62. That gets us 140. So 250 take away 140 leaves us with 110. We now need to divide that by 2. We get 55 for each 4 and 5, so we're going to complete the table, 55 and 55. We were asked specifically for the relative frequency of landing on a 4. So 4 in our table is 55. Total number of trials was 250. All we need to do now is to simplify that. If the question didn't say give your answer in the simplest form, you could leave it like that, but we need to practice because some questions will ask us to write to the lowest value. So we could divide by 5. 5 into 55 goes 11. 5 into 25 goes 5 times, and into 0, 0. So in its simplest form, it is 11/50th. Absolutely brilliant. So guys, now we know how to write down our relative frequency and also know how to do our expectation. Now, this is the 3rd lesson in our series. So of course you're looking for lesson 4 and 5 as well. So make sure that if you haven't done so yet, guys, I fail to believe you haven't hit all yet on the notification bell so that you can receive all uploads. And also we are uploading our shorts as well to get ready for our exams. I'm working through exam practice papers, and remember you can also find us on TikTok where you will find additional questions as well. So go ahead, share the video, leave a comment, and just give us a thumbs up. Guys, thank you so much for watching.